Okay, so welcome everyone to the post-contest discussion of Codeforces Round 954, Division 3. So this is TLE Eliminators and I am Abhinav Kumar. So let's get started with the first problem. Okay, so in problem A, we have you are given 3 points with integer coordinates x1, x2, x3 on the x-axis, and you can choose any point with an integer coordinate A on the x-axis. Note that the point A may coincide with point x1, x2, or x3, and then it's given let FA be the total distance from the given points to the point A. Find the smallest value of FA. So what we basically have to do, like we are given these 3 points, three integer coordinates on the x-axis, and the points lie in between 1 and 10. So the constraints are very small, and you have to just find a point A such that the sum of the distances from A to x1, A to x2, A to x3, this sum is minimized. We have to minimize this distance and find such an A. So we have to find the smallest value of f of A, the sum of minimum distances. So it's very simple what we have to do. Like if we are given a number line and there we are given like 3 points from between 0 to 10, we are given like 3 points, let's say x1, x2, and x3. What we have to do, we have to find a point A. So we have to find a point A. Let's suppose I took a point A here. So what would my FA be? So FA is equal to distance between from A to the 3 points. So this distance plus this distance plus this distance. The sum of these three distances would be FA. So like my FA is going to be just the absolute value, what is distance between x1 and A? It is the absolute value between x1 minus A, and distance between x2 and A, it is absolute value x2 minus A, and from x3 it would be x3 minus A. So this is the value of FA, and we have to find this minimum value of FA. So we can take point A. What can be the different values for point A? We can take A is equal to 0 to A equal to 10 because if let's say the smallest is x1 and largest is x3, we're taking somewhere this side. So it's going to increase the distance. So with minimum distance, we are only going to require to start with the minimum of the three. If you start from the minimum of the three and end with the maximum of three, in between these range only somewhere and A would lie, which would be a minimum A. So you can just brute force it from 0 to 10 or brute force it from min of x1, x2, x3 to max of x1, x2, x3, whatever you wish to do. Like constraints are very small, you can just do anything. Okay, so you can just brute force the solution. So for every A from 0 to 10, you can just go and just find this FA and just take a minimum. So you can take a variable, let's say min, and you can initialize with it with a very large value, let's say 1e9, and then you can just say mn equal to min of mn comma FA. So where you can calculate FA as this value, you can write that here. So in this way, you can just do it. Okay. Uh, this is a simple code for this. So what I just do the three values in a vector. You can just take it directly also x1, x2, x3. I took a vector and of size 3 and took the three values, and then I sorted it so that I have to traverse from the minimum to the maximum. You can just traverse from 0 to 10 and no need of sorting and all. You can just do like this. You can traverse from 0 to 10, this sorting. This would also be sufficient. Okay. You can just do like this. Okay, so this would be accepted. Like any more doubts in this? This was a very simple problem. I hope you all would have done this. Okay, what would be the complexity of this? So you are just running a loop from 0 to 10. So complexity is just O of 10, you can say. Okay. So I hope the first problem is clear to you. Let's move on to the second problem. Okay, now in the second problem, you are given a matrix of size n cross m, where the rows are numbered from 1 to n from top to bottom, and the columns are numbered from 1 to m from left to right. And the elements at the intersection of the ith row and the jth column is denoted as Aij. So you are basically given a matrix of size with n rows and m columns. And this is the denotation Aij represents the ith row and the jth column. Now consider the algorithm for stabilizing matrix A. Find a cell ij such that its value is strictly greater than the values of all its neighboring cells. If there is no such cell, terminate the algorithm. If there are multiple such cells, choose the cell with the smallest value I, and if there are still multiple cells, choose the one with the smallest value j. Okay, so and then set Aij equal to Aij minus 1, and then again go to step 1. So what basically this is saying is, so you are basically given a matrix. Okay, so let's suppose you are given a matrix of with I rows and j columns. So like 1, 2, 3, 4, 7, 10, 5, 9, 0, 3, 4, anything. Okay, let's say you are given a matrix. So what you have to do, you have to select the such a element Aij such that this Aij is greater than its neighbors. So let's say if you are selecting this as an element, then it should be greater than all its neighbors. It should be greater than this, it should be greater than this, greater than this, greater than this. But here you can see 10 is not greater than 16, so you can't select this. But if you select 16, you can see it is greater than 3, greater than 10, greater than 3, greater than 5. So you can select this 16. Now you have to, if there are multiple elements which can be selected, you have to select the one with minimum I first and then minimum j. So basically you have to start with I equal to 0, like go like this, and then like this and like this. And the first element you get, which is an element greater than all its neighbors, you have to select that element. Okay. So if we will start checking from this, if this is greater than all its neighbors, no, it is not greater than 8. This is not greater than 10. This is not greater than 16. This 4 is not greater than 5. You can see this 8 is not greater than 10. This 10 is not greater than 16. Now, when we come to this 16, this is greater than all its neighbors. So we will select 16, and what we can do, we can do Aij equal to Aij minus 1. This is the operation we have to. So we have to just reduce its value by 1. We will make it this 16 as 15. Okay, so this is one operation. Now you have to repeat this operation again and again until there are like you can reach the last value and there are no element which you can select and reduce it. So once you reach that stage where you cannot make any operation, then that is your final matrix and you have to find that final matrix. Okay.
Sorry, I
Now,
didn't ask, but I mean, repeat the process means what does it mean?
repeat. So like the first process which I explained, you have to start from this and go and find such an element which is
Now this
greater than its
process will
neighbor.
come after 16 or again from 1?
Again, so like you have to start the process again starting from 1. So what the question says, it is that only. You have to start from again from 1 and then check which is the first such an element which is greater than its neighbor. But if you like look at this, if 16 was the first element where you can perform an operation, then all the remaining elements in the next step also they would not come
Yes,
actually if
agree.
you
Yes.
see. So according to the question, you have to check. But if you apply the logic after that, then you would realize that you actually don't need to check the remaining, because what change you are making? You are reducing this 16 into 15. So if let's say some element 10 was not greater than some element, and let's say 16 was greater than 10. And if you are reducing this into 15, you can at max reduce this to 10, but not less than 10. So this 10 would never become a like a peak element, or whatever you can say, element which is greater than its neighbor, because it would never happen that this 16 gets reduced below 10. Okay, that's the thing you have to notice here. So what actually it is going to happen? If you like perform the operation again and again, you will have to perform, what is going to happen is this 16 would again and again get selected. It would first be reduced to 15, then 14, then 13, then 12, then 11. Till here it would be reduced, and then till 10 also. So let's say it's reduced till 11. Okay. So like till here it's clear now, because till 1 to 10, we were not able to select any element, because someone was not greater than all its neighbors. But 16 we were able to select and reduce it to 15. And then when we repeat the process again, we were again able to select that 15 and reduce it to 14. So this way we were able to reduce it till 11. Now, when we select this 11, we can again see it is greater than all its neighbors. We can now reduce this 11 to 10. But after this, once we are done till here, now if we select this 10, this is not strictly greater than 10. So we cannot apply an operation on this. Okay, so now we can stop here and move forward. We can check forward. So we can now check 5. Is it greater than its neighbors? No. We can check 9. Is it greater than its neighbors? Yes. This 9 has only two neighbors, 8 and 0, and it is greater than its neighbor. So now what would happen? This 9 would be reduced to 8. Okay. And once 9 is reduced to 8, now again the process would repeat. But you already know, all those which were not being able to get selected, after performing an operation, it would never happen that now they can be selected. So we actually don't need to check these all again. Once they are checked once, they are at their final value, we can see. So we need to check every element once only and reduce it until it is greater than all its neighbors. So now 9 is reduced to 8. Okay. So now again we can check this 8. Is it greater than its neighbors? No, this 8 is equal to it. So it's not greater than its neighbor. You cannot reduce it. Now we'll check 0. It's not greater. Then we can check 3. It is not greater than 10. We can check 4, not greater than 5. So this is the final matrix that we would get that we need to print. Okay. So what we actually need to do, we have to just go to every element. And one more thing, like if we are on 16, we, instead of reducing it one by one to 15, 14, 13, we can actually reduce an element to the maximum of all its neighbors. So among all its neighbors, if this was 16, then among all its neighbors, it had 3 as its neighbor, 10, 3, and 5. So among them, the maximum is 10. So it means 16 would be reduced to 10. That's what is going to happen. It would take 6 operations to reduce this 16 to 10, but we are not requiring to find the number of operations. We only have to find the final matrix. So we can just directly reduce the 16 to 10, because we know again and again this 16 would be reduced to 15, 14, 15, 10. Because if we are doing one by one, then the time complexity would exceed, because these numbers can be up to 1e9. So it would go 1e9 into the and into m if we are reducing one by one. But this way we can reduce this 1e9 to 1 and do in O of n into m. We have to traverse each element only once. If it is greater than all its neighbors, reduce it to the maximum of all its neighbors. That's what we are doing. Okay, so like, is this thing clear what we are doing? What if it was 17 below 16? So then 16 would not be selected. Yeah, someone has already replied to that. Okay, so is this clear? Is there any more doubts in the logic what we are doing?
I mean, like the above is the output we need to give, right? Apart from 16, we need to change it to 10, and the above is the output we need to give. Am I correct?
Yeah, 16 would be changed to 10, and what you said?
And above is the final output. Am I right?
Yeah, in this here only 16 would be reduced to 10, and then this 9 was reduced to 8, and so this would become my final output.
Okay, sir, got it.
Yeah, so we'll just start with the first element, go in this way. We'll start with I equal to 0, then go for j from 0 to m this way. So I will go from 0 to n, and inside that we will go from j from 0 to m. And in this way, we would just check this aij. If it is greater than, if it is not greater than any one of its neighbors, then no need to change it anything. This would remain what it is. And if this aij is greater than all the neighbors, what we would do? We would assign aij as maximum of among the neighbors. Okay, we would assign aij as the maximum among the neighbors, and this would become the final value for that aij element. This way we can just traverse all the element, and what we get would be our final matrix. That's what we have to do. Okay, is the logic clear? We can go to our code now. Okay, so now what I'm doing here, so I've taken the input this here, and after that I'm running a loop from 0 to n, and inside that I'm running a loop from 0 to m. Then I've taken a mx variable to store the maximum among all the neighbors. So like if I is 0, then there is no neighbor to its left. So if we are checking the left neighbor, which is a I minus 1 comma j is its left neighbor, then we have to give an if condition that I should be greater than 0. Otherwise, if it's on the leftmost boundary, it won't have a left neighbor. So if it has a left neighbor, we will maximize mx with a I minus 1 j. Now, if it is not on the rightmost boundary, that is, it is less than n minus 1, then we can have a right neighbor. So right neighbor would be I plus 1 comma j. Now, if it is not at the topmost, then it would have a top neighbor, above neighbor. If it j is greater than 0, then ai comma j minus 1 will maximize this, and then a bottom neighbor. If it is not at the bottommost boundary, then it would have a bottom neighbor. So ai comma j plus 1. Okay, so in this way, we have found the maximum among all the neighbors. And if it has any neighbor, then mx would not remain 0, because we are given the values are from 1 to 1 in n. I had taken a 0 in my example, but 0 would not exist. Minimum value would be 1. Okay, so that's why if we are initializing mx with 0, so if there are no neighbors, mx would remain 0. So what
Sir,
we have to do?
sir,
Yeah.
if we take one base indexing in the array, then we should not use this type of edge conditions.
Yeah, you can do that. If you take a one-based indexing, then you can just initialize that 0 index with the like you have to take the maximum. So you can initialize that 0 index with 0. So in that way, it would be okay. You won't have to check this if conditions. Yeah, you are right in that. Okay, you can do like that. You take one-based indexing, then I minus 1 at 1, it would become 0. So 0 index you can initialize with 0. So max of anything with 0 would not affect our answer. Okay, so this way we have found the maximum among all the neighbors. And if this maximum is less than our value, then we would assign this maximum to our value. Otherwise, it would remain as it is. And then we can just print this value. You can do the printing part outside also, but I have done here only. You can do like you can calculate these metrics and then do the run run the same loop and do the see out and see out the expression. I have done it together only, because once this element is checked, it's finalized. It's not going to change. We are sure about that. That's why I've printed it here. You can do it outside. Okay, so is the code clear and everything clear here? What would the complexity of this code be? We are running a loop from 0 to n and 0 to m. So n into m here, and this is just a constant time operations. We are running 4 if conditions and the out and 5 if conditions. Okay, so this is a constant time operation. N into m complexity would be O of n into m. Okay. And we are given here that n into m doesn't exceed 2e5, so it's accepted. Okay, so now we can move to the next question. Okay, so now we have problem C. Let's consider the following simple problem. You are given a string S of length n, consisting of lowercase Latin letters, as well as an array of indices int of length m. Okay, and string C of length m, consisting of lowercase Latin letters. Then in order you perform the update operations, naming during ith operation you set s of index I equal to ci. So this is the operation you have to perform for every I. Okay, note that you perform all m operations from the first to last. Okay, so we have to perform some operations. We'll discuss what we are doing here. Okay, of course, if you change the order of indices in int and or the order of indices in string C, you can get different results. Find a lexicographically smaller string S that can be obtained after M update operations if you rearrange the indices in array and then the letters in string as you like. Okay, so let's discuss what we are doing here. Okay, so as an input, we are given a string S, which is of length n. Okay, you are given an, okay, n is also given as an input. Okay, n m. Okay, first you are given n m, these two integers. So then you are given a string S, and the size of this S is n, and then you are given a string C, and then also an array of indices m. So the size of these two is m. Okay, so you are given these things. So basically you are given three things. You are given a string S. So S is a string of some length n. You are given an array of indices. Okay, so this is an array of indices. So it is containing integers, and the range of these integers would be from 1 to n. Okay, so it is actually consisting of the indices of this string S. Okay, and then you are given a string C, which is of length again m. This was also of length m. Now, what does this C represents? So what actually we have to do? So if these S, int, and C they remain the same, then what would happen? Let's say you are given S is equal to A, B, C. Okay, and you are given an array of indices. Let's say this is of size 4, 1, 2, 1, 3, and then C is given as let's say Z, Y, F, B. Okay, something like this. So what the question says, what you have to do, uh, you have to start from this. Okay, you have to go to each element of this int. Okay, from I equal to 1 to m. So if you take, let's say, I equal to 1, then it means you will change S of int I is equal to Ci. That's what it was written in the question. What does it mean? So what is int I? Int I means this value. This is 1. It means you will change the first index of S to this value. So what you would do, you would change the first index of S, this A you would change to Z. Okay, this A you would change to this value Z. Then you saw in the second place, we had an index 2. So, okay, here you changed A to Z, then you had index 2. It means you will change the second index of S to Y. This is what it means. So B would be changed to Y. Now you again got a 1. It means you will change the first index of S to F. Okay, so this again, first index would be changed to F. Now you get a 3 here. It means the third index of S would be changed to B. Okay, so this is the third index, it would be changed to B. So finally, the S you get would be F while B through these operations. Now, this is basically, if you have an S index and C, this S would be transformed to this. So this is basically the operations. Now, what the question says, you can rearrange this array of indices and this string C. So rearrange means you can just shuffle these array, shuffle these values, and then shuffle these values also. So after shuffling, now you have to shuffle in such a way so that you now what you the index and C you got, according to that, if you apply the operations on S and you get the final, let's say S dash, this was S dash. So you have this S dash should be lexicographically smallest. You have to shuffle them in this way so that the final S dash you obtain, it should be lexicographically smallest. Okay, that's the question. Okay, so is the question clear? Then we'll move how like what we can do here. Okay, so okay, now the question is clear. So what we can do, if you look at this array of indices and see, if you take a closer look at this, in indices we are given an array of size m. Okay, we are given some elements n, and in C we are given some like characters A, B, C, D, something like that. We are given some characters. Okay, let's say. And what is happening? This you can say these two are linked. You can it means the value that would be here. If there is a 3 here, it means S of 3 would change to the value 8. It means you can just store them like the index 3 would be changed to A. You can represent it like this. If there is a 4 here, it means index 4 would be changed to B. These two are connected. Same way, all these would be connected. Okay, and like last you can say index whatever at M, if you get 10x, so index x would be changed to whatever you have here. Okay, let's say this 5. Okay, 5 would be changed to like that. You can write it. Okay, now what you can do, you can shuffle this thing and shuffle this. It means okay, one more observation you can notice. It is the changes are taking in place in order. Okay, in serial order. So if there's a 3 at index 3 is changed to A, and again if you get a 3 and that is changed to C, it means in your final string S, what you would have at index 3, you would have the value which is coming later, because first that value would be changed to A, then A would again be changed to C. So it would be C. So it doesn't matter what you put here, it has no significance. The for 3, the last character that 3 gets, that would be the value at index 3. Okay, so if in this array you are getting some indices as the repeated ones, you can actually take it only one time. So the last occurrence of that, only that would matter. Before that, whatever you're getting, that doesn't matter. So you can actually have a set. You can just store these indices into a set so that they are unique. You only require a unique of if there are 3 threes and let's say 2 twos. So what happens at this 3 and at this 3, it doesn't matter. What happens at this 3, only that matters. And what happens at this 2 doesn't matter. What happens at this 2, only that matters. Only the last one would remain in this string. Okay, so you can store all these indices into a set so that all the indices are unique. Okay, so let's say you get a set and that set would contain some elements among 1 to n. Okay, let's say it contains 2, 4, 5, and 7. Okay, these are the indices that this set contains. Okay, so now what you would do with this string C, what you can do with this? So what you have to do, you have to make this the final S you get as lexicographically smallest. What do you understand by lexicographically smallest? It means if you have like two strings A, B, C, okay, let's say A, B, C, and then A, B, B, C, something like that. Which would be lexicographically smaller? So you will just compare the first index. If they differ, then whichever character is smaller, that would be smaller. Here A is equal to A, so you go to the next. Then A and B. Among them, A is smaller, So this first string is smaller. It doesn't matter what happens with the remaining characters. Like it doesn't matter in the remaining characters, even if after AA you have all AA, let's say all ZZZ here, and here after AB you have all AAA. You have all Z here and A here, but here you had an A which is less than B, so this would be lexicographically small. So in lexicographical order, the leftmost characters matters the most. Okay, so we would first try, what we can do, we can just do this greedily. We would first try to, whichever is the smallest index in our set, we would first try to minimize that index. So if you have a set of 2, 4, 5, 7, we would try to change this second index to the minimum character we can have. Then in that case, we would have the lexicographically smallest one. So what you can just do, if you have this C, if this C has characters A, B, C, Y. So among them, we would choose the smallest character and assign it to 2. So in C, you had A, C, B, Y. Okay, let's say this. So among these characters, you would assign the smallest to this 2. So the smallest was A, you assign A to 2. Now next you have 4. What you would assign to the fourth index, the next smallest. You would assign B to 4. What you would assign to 5, the next smallest, which is C. And then to 7, you can assign the next smallest, which is Y. Now, let's say you had more elements, ZZ also. It means the more elements you had, you can assign those to the repeated ones. So in actual, you would have maybe 2 2s and 2 times 7. So when you put it into a set, this 2 and this 7 was ignored. So what you are actually doing is assigning these Z to those ignored characters. Okay, you can, because those would anyways get ignored. So the bigger characters you can assign to them so that they do not come in your final string. You want to minimize the characters. You want to make it lexicographically smallest. So you would want to utilize those bigger characters into those indexes which does not matter. So if you take an example here, you have a string, let's say A, D, C, E. Okay, and let's say you have C equal to, okay, not say first, let's say this index array is 2, 2, 6, 4, 4, and 7. Okay, this is the index array. Okay, 7 you cannot have. It's a size 4. 6 also you cannot have. You would have only from 0 to n. Okay, so let's say this is 3 and this is 3 again. Okay, let's say you have this as the index, and let's say in C you have as Y, Z, B, F, C, A. Okay, let's take this example, what you can do here. Okay, so if you take this example, what I am saying is, first you will convert this index into a set so that you have unique characters. So when you get a set from this, what you would have here. Okay, so if you convert this into set, the set would contain 2, 3, 4. Okay, so it means when you will change this string, this 2, 3, and 4 would be changed to the character you are assigning from C. Okay, and this index 1 which is not in the set, so it means it's not there in the index array, so it would remain as what it is. It's not going to change because we don't have 1 in this index array, so this is never going to get changed. So this would remain as A, but these are going to change according to our array C. Okay, our string C. So what we would try to assign to these. Okay, now what the string C, in string C, what characters do you have? You have Y, Z, B, F, C. So let's sort this C so that we can pick the smallest character first. So we can pick A, then B, C, then F, then Y, then Z. So this C is sorted. Okay. Now what we can do, to the second index, we'll start with the smallest index. We'll try to minimize the smallest index first, because in lexicographically we can do it greedily. Just minimize the smallest index, best thing, and then same way for the next indexes. So for 2, we can assign the smallest, that is A. For 2, we can assign A. Okay. For 3, we can assign the next smallest, which is B. For 4, we can assign the next smallest, which is C. Now, what would happen to these F, Y, Z? So those would be assigned to the repeated characters. So 2 was repeated 2 times. So this 1, 2, which was lost from our set, and this 4, which was lost, and this 3, which was lost off from our set, they would be assigned these F, Y, Z. Whatever you want to assign, just assign them. It does not matter, because they would be replaced by these. Okay. So what would be the final string that you get? So index in the final string, this index 2 would be replaced by A. So you can just replace this index 2 by A. Now, this index 3 would be replaced by B. Index 3 would be replaced by B. So you can just do index 3 is replaced by B. And this index 4 would be replaced by C. Index 4 would be replaced by C. So what you can do, you can just replace this index 4 by C. So what is the final string that you get? It is A, B, C. This would be your final answer, which is you are going to print. These F, Y, Z does not matter, because they are not going to, we are not going to have them in our answer. Okay, so this string would be our answer. So that's what we have to do. So what basically in the code we have to do? Put this index array into a set. Okay. Sort this array C. These are the 2 things we are going to do. Then start from the smallest character, smallest index in the set, and one by one assign these sorted from C, one by one just assign these characters to that index in S. If you just replace it one by one, you are going to get your final answer. Okay. Is the logic clear? Okay. Is there any doubt what we are doing? So I would explain with another example if it is not clear what I wanted to say. Okay. Let's try to understand from the code. I will explain more in the code. So what I did, I just took this N and M as input and the string as this vector indices and the string C. So I've taken all the input here. Okay, whatever was given. Now, what I am doing in a set ST, I am storing this full array of indices. So what I'm basically, this is actually index.begin and index.end. I've written all index, but it's index.begin, index.end. So I'm just storing this whole array of indices into a set. I'm putting each element of this into a set. Now in this set, we have all the unique elements from this index array, and they are also in our sorted order, so that we can just directly traverse this set in ascending order only, which we needed to traverse for lexicographically smallest order. Then what I did, I sorted this array string C. I sorted this string C according to the smallest character to greatest character. I have sorted it. Okay. So these are the 2 things I did. What I told, I put all the index array into a set and then sort this character C. Then what I'm doing, I'm assigning this j equal to 0. So it is my pointer for the string C. So we would start to pick characters from C, starting from index 0. So, and then what we have to do, we have to just traverse this set. So we would traverse this set that we got. And if we have I, so in the question, it was given as a 1 based indexing. But here, when we take this string, it would be 0 indexed. So I'm assigning S of I minus 1. Okay, so because I'm converting from 1 based index to 0 based index, that you can understand. Okay, so this is SI actually in 0 based index. That's why it's I minus 1. So this I'm putting as C of J. So it's actually C of j, and after putting it at C of j, I'm just putting j plus. Okay. This is the same thing. So I'm assigning the character Si as C of j, where j is starting from 0. So this C is sorted. So first it would assign the smallest character, then j plus plus. Then next, to the next index, it would assign the second smallest character, then the third smallest character. Likewise, it would assign, and we can just print S. This is what we are doing. Should we also sort the indexes? I am putting the indexes into a set, and the set would already be sorted. Okay, so like if you're putting in a vector or something, then you would have to sort. But a set is already sorted. That's why I'm just traversing from the set. So no need to go. Okay, it's clear. So I hope this problem is clear and the logic is clear. What would the complexity of the code be? So I am taking the input. This is of size n and size m. So n and m are coming. And then I'm putting this m values into a set. So insertion of each value takes log n time. So this putting all the values into a set is going to take actually O of m into log m time. Okay. You can understand because there are m elements into index, and each insertion would take log m time. So a total of m log n time this operation would take. Okay, then we are sorting C. So C is also m. This would also take a sorting takes time complexity of m log n. So this would again be m log n, and then we are just going to each element of this set and assigning S of I as j. This is O of 1 operation. So a total of m here. So this is a complexity of O of m. So when we add all these, we get an overall complexity of m plus m log n. And this n is the size of this string. So it would be like O of, you can say, n plus m. Okay, this would be our complexity. Is it clear? So, and m and n are of the range 2e5, 1e5. The sum would not exceed 2e5. So 2e5 log that m log m is optimal. Okay. So this is the third problem. Now we are going to move to the fourth problem. Okay, so in the fourth problem, what we are given, you are given a string S of length n greater than 1, consisting of digits from 0 to 9. You must insert exactly n minus 2 symbols plus or multiplication, any of this symbol, into the string to form a valid arithmetic expression. In this problem, the symbols cannot be placed before the first or after the last character of string S, and two symbols cannot be written consecutively. Also note the order of digits in the string cannot be changed. Let's consider S equal to this. So what we can do is, we are given a string S. Now you have to just convert this into an expression. So in the expression, obviously, you cannot place a symbol before the first character or after the last character. So you have to place somewhere in the middle. You have only two symbols, addition and multiplication. Okay. And you have to place n minus 2 symbols here. Okay, so if you are given a string like this, you can make these expressions. So this is one of the expression. You put a multiplication here, plus here. Then you took two characters together, then a multiplication, then plus here. Okay, or you can make this expression. Okay, likewise, you have to place n minus 2 symbols. That's the important thing. So if you have a string of size n, how many gaps you would have to place symbols? Either you can place between the first two, or between the next two, or between these. So you would have actually n minus 1 gaps here. Out of those n minus 1 gaps, you have to place n minus 2 symbols. So actually there would be only one gap where no symbol would place, and these two numbers would be concatenated together. Like this 70 together make 70. 98 together make 90. Okay. So likewise, all possible combinations we can have would be just for each place, if you are not putting any character. So first you can put 98 together, then 87 together, 72. Okay, we'll discuss that. Okay, so this is the problem. You have to form arithmetic expressions like this and then calculate the value of that arithmetic expression. Now what you have to do, so also it's given you can consider 0, 9 as together. So with having a value of 9. So it's not that you cannot have leading 0, you can have leading zeros also. Okay, now what you have to do, the final result of the operation you obtain. So expression you have to evaluate first multiplication and then addition, like you do in good math. Okay, then you have to just calculate the minimum result you have to obtain among all of them, all the possible combinations you can have. You have to find the minimum result that you can obtain by converting it into an arithmetic expression. Okay, and we are given n as 20 only. So the constraints is very less only. So now you have to find the minimum result. Now what you can do here. Okay, first let's take an example from here only. So let's say you have this number. Okay, let's say you have this. So now what you can do here, the 1, 2, 3, 4, 5, 6. There are this is a string of size 6, and you have total 6 characters here. So n is equal to 6 here. Now, how many symbols you have to add plus for multiplication symbols, which is n minus 2. That is 4 symbols you have to add. Now, if you take a look at it as 9, 8, 7, 0, 0, 9. Okay. How many gaps do you have? You have a gap here, a gap here, a gap here, a gap here, a gap here. So 5 gaps in total. So always there would be n minus 1 gaps. Now you among these n minus 1 gaps, you have to place 2 symbols. Okay. So there would be one gap where there would be no symbol placed. So let's say if this is the gap where no symbol is placed, then this 70 would be together and all these would be like individually only. So first thing, what among all possible combinations, first what you can do, you can just one by one check. Let's say I don't fill this gap. Then you would check, let's say I don't fill this. Then you would check, let's say I don't fill this gap. So likewise, one by one, n is only up to 20. So in O of 20, like these 20 operations, you can just form these combinations. If I don't fill this, if I don't fill this gap, if I don't fill this gap. Okay, then what you would have to decide is it would become a little simpler. So let's say what I did is I decided that I would not fill this gap. Okay, so it means what numbers do you have? So you would have a 9 and then some symbol, then 8, then some symbol, then this 70 would be together because I'm not filling this gap, then some symbol, then 0, then some symbol, then 1. So your final expression would be of this form, fill this gap. Likewise, one by one you would check for each gap. Once you would set this gap as unfilled, once you would set this gap as not filled. Likewise, you would check. So let's say I'm checking for this gap is not filled. So this is the expression that I obtained. Now what you have to do, you can add a plus sign here, a multiply sign here, a plus here, multiply here, anything you can add. And you have to minimize this expression. Now, which sign would you add so that this expression is minimized? Okay, so if you look at this expression, the first thing like you can observe is if you have a 0 somewhere, if you have a 0 here, what you can do, you can just add a multiplication sign everywhere and this whole would be multiplied and we would get a 0. The minimum you can obtain can be 0 only because you are given all positive numbers here. Okay, There are no, like, you cannot have a minus sign. All are positive numbers. Among positive numbers, if you get a zero, you just blindly multiply all numbers and get zero as your result is would be your minimum. So that is the first case, first special case. If you get any zero, you can just multiply all of them and get your final result as zero. Now, what if you don't have a zero? Let's say you had a 1 year. Okay, let's suppose you had a 1 year. So I'm making it a 1. Now, if you look at this expression, you have 9, 8, 71, and 9. You don't have any zero, you cannot multiply and make it zero. Now, what is the minimum you can obtain here? Now, if you try to think, if you are multiplying, let's say 8 into 70, you're getting a very big value. So here you would always try that you add them up. This 9 and 8 also, if you multiply, you would get some bigger value. Adding would also always be better instead of multiplying. But if you look at 70 and 1, if you multiply them, you get 70. But if you add them, you get 71. So in this case, multiplication is better option. Again, if you look at 1 and 9, here if you add them, you would get a 10. But if you multiply them, you would get a 9. Here also, multiplication was better option. But if you don't have a 1, if you have anything greater than any two numbers which are greater than 1, even if you have 2 and 2, their sum would be 4. 2 into 2 would also be 4. So in this case, you can have anything and anything more. If you have 2, 3, so 2 plus 3 would be 5. 2 into 3 would be 6. Again, always multiplication would be greater. So addition would be a better choice. So if you have two numbers which are greater than 1, then I am saying that always addition is better. Is this thing clear? If you have 2 and 2, then both would be same. So you can take addition. But anything greater than that, 2 or more than 2, always addition would be better to perform. Because if you are performing multiplication, you would get bigger values. Like, do I need to provide any proof for that, or is it like logically understandable? Okay, so it's clear. Okay, now, so this is the thing. So if you don't have any 1, if I had 2 here, so what you would do, you would just place all the plus signs, and this would be the minimum value you can obtain. You would not do any multiplication. You would just add up all those values with the plus sign. If you don't, if the minimum value in this is 2, then you would add up all. If the minimum value is 0, you would multiply all. Now, only case remaining is if you have a 1 somewhere. Okay. So if you have a 1 somewhere, what you can do? You can have a multiplication sign, let's say here. Then the 17 to 1 would be 70. But if you have a multiplication sign here, then 1 into 9 would be 9. But let's say you have multiplication signs here also, here also. Then you would get 70 into 1 and then into 9. You would get 17 to 9, which would be a very big value. Instead, what you can do, you can have a multiplication sign at any one place and an addition sign at one place. If you do it like this is an addition sign. Then 9 into 1 would be 9, and then you would have 70 plus 9. This is one option. Or what you can do, you can have a multiplication sign here, addition sign here, then 70 into 1 would be 70. This would be 70, and 70 plus 9 would again be 17. So like in this both cases, you are getting 79. So actually what you are doing, if you have a 1, you can just ignore that 1 and add remaining values. That's what final value. Here you would place plus and plus. So if you have a 1, so you can have a multiplication sign either to the left of 1 or to the right of 1, and addition sign at the remaining places. So let's take one more example. If you have 7, 9, 0, 1, and 1 again, and then 5. Let's say you have a string like this. You decided to not place a symbol at this position, so you got a 0, 1 together, and this 7, 9, 1, 5. In this case, what you would do, if you have a 1, you would place a multiplication sign either to just decide one thing, either left or right. Let's say you are putting at left, so multiplication sign to the left of this, to the left of this. Remaining you would place for plus signs. What you would get, 9 into 1 into 1 would make it 9. 7 plus 9 plus 5, you would get the sum of these. So what is the final result you are getting? It is actually the sum of all the numbers except 1. So if you sum up all the numbers except 1, that's the final result you are getting. That's the minimum value you can obtain. Take 2, 2, 2, 1. Okay, let's say, let's take a 2, 2, 2, 1. So like first you will decide. So for let's say you are not placing any character here, you would put 22, 2 and 1. Then what you can do? You can, before 1, you would place a multiplication sign here, and then plus sign. You would get 22 plus 2. You can just ignore this one, and a 24. One by one, you would do this for every place. So first, if we take this place, you get 24. Now let's say I'm not placing any symbol at this place. You get 2, 22, and 1. So before it here, you would place a multiplication and a plus sign here. So like this, you get a 24 again. Now let's say this place is the place we are not putting a symbol. So you get a 2, 2, and 21. So here there are no ones, so you would add only plus signs. So you get a 25. Now among these, whatever is the minimum value, you would take that. So minimum is 24, 24 would be your answer. That's what you have to do. Okay, how do we decide which 2 digits we take? That we would do the brute force for every possible combination. Which 2 digits we take? Like I told, if you had this string, what I did, first I took these 2 digits. This is the first case. This is, let's say, case 1, you got a 24. Now case 2, I took these 2 digits. In case 2, I got a 24. Now case 3 was these 2 digits. In case 3, I got a 25. How many possible cases you would have? At max, n is given up till 20 only. So at max, there would be n minus 1 cases only. Okay, or n minus 2 cases there would actually be. So like 18 cases, you can analyze those O in O of 18. And for every case, what you are doing, you are just summing up according to 3 rules. First is, if there is a 0, if there is 0, then our output would be 0. If there is no 0, so if there is a, let's say I'm telling, if smallest value is 0, okay, we can just take the smallest value. Smallest value is 0, we take 0. Okay, and if the smallest value is 2, so all are greater than 2, we'll just do sum of all the elements. Okay, and if the, like, not 2, greater than equal to 2, anything is greater than equal to 2, we'll just sum up because there is no 1. And if the smallest is 1, now what we are doing in this case, we will sum except 1. We will sum each element except 1. Now one more, a small edge case we are getting in this is, let's say you have 1, 1, 0, 1, something like this. So if you are placing these together, you get 1, 1, and 0, 1. You have to place symbols here. So if you sum up all those 1, 1, 1, excluding 1, it means you are not adding 1, you would get 0. But what we get here is product all of them and get 1. 1 is the smallest value you can get. So if you have all ones, so you would sum except 1. And if this sum comes out to be 0, then you would make it 1. That's the one small edge case you have to handle in this. Okay. So this way you can cover, in these 3 cases, you can cover all of them. Okay. So this is the way for calculating once we have decided which is the place where we are not placing a symbol. Once we have decided this, after that we will calculate our answer using these 3 cases. And the answer we calculated will minimize for all of the cases. So among all the cases that we got, like this, if you got 3 cases, Then among them, the minimum value is 24. So we would give 24 hours as our answer. Okay. So is the logic clear? Uh, can you repeat these three cases? Okay. So like, do you want me to repeat or is it okay? Like these three cases, no? Smallest is 0, 2, and 1. These three cases you are telling me. Okay. Yeah, it was not a DP problem. It was greedy. Although you can apply DP also here if you were like doing from a brute force perspective. But I like tried for a brute force thing going 2 to the power 20. But like after that, I got this simpler logic. So I implemented this only because the complexity of this logic would be like 20 into 20 only. But if you are given n as 20, you could have also done something of 2 to the power 20 into 20. This complexity would also get accepted. So brute force solution of going to all possible cases was also there, which could have been done. Okay, but I got this there, but one problem there was if you get some plus and multiplications, you had to apply the board mass rule and do the multiplications before one. So that was a little. So I thought of using. Okay, so let's leave that now. What if smallest two-digit number is 11? And so 1 is just 2. Sir, what will be answer for? Okay, so first let's discuss that. For 1101, I okay, I had discussed. So first you would take, let's say you are taking this as not empty. So for this case, you would get a 0 and you would get 0 as your answer. If you are taking this as a place where you are not placing anything, then in this case, 1, 10, and 1, you would just do a multiplication symbols here and get 10. So you are just adding up all, excluding 1, you got 10. And then the case was if you don't place anything here, so 1, 1, and 0, 1. In this case, you would just multiply all of them. And among these three cases, the minimum is 0, so answer will be 0. So is the 1101 case clear? Okay. Like I did not understand Laksh what you smallest two is 11. Yeah, I think if you would have got in this case here, you had an 11. What you are doing? Yeah, you can unmute and say. So, unmute and say whatever doubt you have.
Hello, am I
Yeah,
audible? Yeah,
yeah,
so
yeah.
what I was trying to say is like, I didn't say that n is just up to till 20. So I was trying to do it in like big O of just n. Okay. And in that, I was trying like first we could just count the number of zeros. So if there is even a single zero and n is greater than like 3, like let's leave for 2, 3. Those cases I handled separately. And if n is
Yeah,
greater than 3, the answer will be 0 in every case if there is a single, just even one zero present. Okay.
yeah,
Then, if like let's say there is no zero present in the string and the smallest number is 1. So what I was trying to do is like, uh, just iterate through the string and add up all the digits other than 1, and then check like what can be the smallest two-digit number. But it wasn't working. Like, could you also explain why wasn't this working? Like, it's the same thing as you are explaining.
yeah. So like what you were doing is if you have the smallest number as 1, so let's say something like this, then just sum up all the digits excluding 1. That's what you were
Yeah,
doing now.
like first I checked which two-digit number is uh, the
Okay,
smallest
this
one.
okay,
Yeah,
so
and I
from
skipped that number
them and okay.
and
So if
added up
you
the rest other than 1.
okay, you skip that number and that number you are adding at the last.
Yeah, I'm adding at the
Yeah.
last.
Okay,
but this
so
wasn't working. Like I was just missing like from answer in like one number. Like in some cases,
okay,
answer was
okay, let
93, and yeah,
if you know the test case, you can tell, or
yeah, like
uh,
the 15th test case. Let me share. Uh, in the example, the 15th test case. Could you just open up the question?
okay, example 15 test case.
Yeah,
Okay, this test
this
case 0,
this case 198116784. Yeah,
1, 9.
this
Okay,
one.
this test case.
Yeah,
Okay,
it's
so
the answer is 93 and I was getting 94 because the smallest number is 1 in here.
yeah, smallest is 1 here.
Yeah, could you explain your approach on this example too?
Yeah, okay, but why your approach is failing, like I can understand from that. If smallest is 11, like what you could have done, you could have taken the except 11, other than 11, what the smallest is. Like maybe it would be 12 here. So you could have done a 12 here. Let me take it there.
But yeah, I'll take it. Like, but 12 also includes a one which could be multiplied and skipped. So
Yeah, that also could be done. Okay, so maybe, yeah, that's why that logic is failing. You
yeah,
would have,
like what if we skip all the numbers other like which include one and then check? Would it
uh,
work?
then, then also, maybe I think if you skip all the ones, it may happen that it would have been better to take an 11 and then maybe those, because if there is, let's say, 999s and 1 1,
Yeah, that's what I did. Like for the first two digits,
so
we can just place a multiplication sign and that would be 9. And then it's a 8 and we take a two-digit number as 11. And then it's
so
a single
in
digit numbers.
11 is working, but in this case 11 is not working, so
Yeah,
it's,
that's the thing. Like we don't know
yeah,
in which
so
case it will work and in which cases it won't.
yeah, so that's why, like, solving in O of n, maybe you can find some way, like I'll also have to think in this approach. So like now I cannot tell, like, for
Yeah.
sure. I would to think, then I
This
can
just
tell,
happened because I didn't see the
because you would
constraints. Like
have
it was
to
just,
check all the edge cases and all.
yeah.
Like there can be more cases here. Okay. Okay. So like my approach, you have any doubts in this? Do you
Yeah,
want
yeah.
me to
Could you please
in
explain
this?
on this? Yeah.
Okay.
Not all
So
the cases, just few cases. Like
yeah,
what were
okay.
you
So
doing?
first, what we are doing, like maybe this is of size 20. So first we would combine these two. Okay, one by one we would combine each character. Let's say I'm combining the first two. We would get a 19 and then 8, 1, 1, 6, 7. Likewise, all of those would be placed. So among these integers that we are getting, what we would do, we would find the minimum. The minimum is 1 here. Okay, so we have three cases of 0, 1, and greater than equal to 2. So if we have a minimum 1, what we would do? Sum all except 1.
Okay,
That's what we are.
I got it now. I got it, got it.
Yeah. So if you have a minimum 1, sum all except 1, minimum 0, then 0,
It's
and
0.
greater than 2, then just sum all. So these two cases can also be combined together only. Some, if you don't have a 1, you would not count 1 anyways. So
Yeah.
actually, you have two cases only. If you have a 0, directly print 0. It's greater than equal to 1, then just sum all except 1.
Check for all the cases, like for all the
Yeah.
combinations of two numbers.
Yeah. And check this thing for all the combination of two numbers. Yeah. Okay. So is it clear now?
Yeah, thanks. Thanks for like taking up
Oh,
my approach.
okay.
And also
So
till which question will we
till
discuss
E,
for this
till E,
contest?
we are- till E.
Okay, okay, thanks.
Okay. And like for others, is this approach clear? Anybody else has any more doubts? Then we'll move to the code of this problem. Okay, so let's move to the code. So what I'm doing here, I'm taking the input string and then s, and then like one small thing, if the n is on 2 only, then we cannot place any symbol. So this base case I'm handling before only. So we'll convert this string to an integer and then just print it. Because if n is 2, we cannot have any n minus 2 is 0. So it means we have 0 uh, plus multiplication symbol. So it would remain as it is. So for this case, we are handling before only and we're returning. Now, if n is greater than 2, what I'm doing, I'm initializing my answer with some very big value. Infinity is actually int max. So I'm initializing my answer with a big value. And then what I'm doing, for each of the cases, I'm just taking the minimum of my answer. So now I have to calculate for each case. Now, how I'm taking the cases from I equal to 0 to n minus 1. So it would represent that I and I plus 1 are together. That's what my loop represents. So if I and I plus 1 are together, I am taking the vector where I'm storing those numbers that I get. So before I would just directly have my whatever character I'm having minus 0, I would get the integer value of that. Okay. So this would be before I would place it like this. Now for the I and I plus 1, this s dot substring I of length 2, it would have the string from I to I plus 1. I'm converting that to integer. That's my next value in my vector. And then from I plus 2 to the remaining values, again, I'm taking single characters, that single character converted to integer. So this way I'm creating my vector. This vector stores all those integer values that I'm having after doing the partitions. Okay. So now I have to add symbols in between these values of this vector. So first what I did, I sorted this vector so that I can get the smallest value. You could have, instead of sorting, you could have just obtained the smallest value using min element function or just running a loop. Okay, because only the smallest was needed. The sorting was actually not needed here. So now I checked if the smallest value is 0, I can just print 0 and return. Okay, so I could have taken min with answer also, but like 0 would anyways be my final answer only. I don't need to check further cases also if you get a 0. So I'm doing return only here. Okay. Now, if you don't get a 0, what I'm doing, I'm sliding sum equal to 0 and just summing up all the elements if it is not 1. So sum of all elements except 1. Just I'm going to the vector and doing if I is not 1, then sum plus equal to 1. Simply. And then one small edge case that I told, if you have a 1, 1, 1 everywhere, then sum would be 0. So in that case, you would take sum as 1. Okay, like in 101 and 1101 case, I had told that if you get all ones, then if you sum up, it would be 0, but actually you would have to do multiply all those 1 and get a 1. So this small edge case I'm handling here, and then answer equal to answer from sum. So this way I'm finding my final answer. So if you see the complexity of the code, it would be the string is taken as input. Now, n times I'm running this. So outer loop is O of n. And then this is again O of n operation I am putting into the vector 0 to I, then I plus 2 to n. So in total, I am going to every element. This is an O of n in total. And then this sort, actually it was not required. It is making it as n log n, but this was actually, you could have taken this minimum. So you can ignore this if you take minimum, that extra log n you won't get. So O of n here, and then just checking, and this is O of n again. This is again O of n. So in total, inside we are having O of n plus O of n, and outside O of n. So overall complexity would be O of n square. Okay. So O of n loop outside and inside 2 times O of n. So it's O of n square. Okay, and n is given as 20 only, so n square is accepted. Anyways. So any more doubts in this problem? I hope this is clear. What would be approx rating of this question? I cannot guess the rating now. I can say maybe around 1400, 1500, 1600, something like that. I cannot guess exactly. Okay, okay, so can we move to the E problem now? Yeah, so let's move to the E problem. So you are given an array of integers and an integer k. So two things were given, an array and an integer k. You need to make it beautiful with the least amount of operations. Before applying operations, you can shuffle the array elements as you like. For one operation, you can do the following. Choose an index I, make ai equal to ai plus k. Okay, so what it is telling, we have an array of an integer. What you have to do, you can first shuffle them as you like. First shuffle the array of elements as you like. And after that, you have to apply these operations after shuffling. So in operation, you have to just pick one element and increase it by k. That's the operation. Now, an array is called beautiful if bi equal to b of n minus I plus 1. What does this thing means? So the other way to say this sentence is that if it is a palindrome, okay, b1 is equal to bn, b2 equal to bn minus 1, likewise. So the first element is equal to last, second equal to last second, third equal to last second. If that is happening, then array B is called beautiful. It means beautiful just means palindrome. Okay. So find the minimum number of operations needed to make the array beautiful or equal to this. So you have to find in minimum operations, how can you make this a palindrome array? Okay, that's what you have to find. Okay, now let's see what you can do. So what you are given an array. Okay, let's take an example. Let's say you are given this array. Okay, so now you are given this array. What you can do is, or you are given also some value of k. Okay, you had one here. Let's take something better. Okay, let's take k equal to 2 here. Okay. Now what you need to do, you need to first you can shuffle this array as you like, and then you have to do the operations. So let's say you shuffle this array like this. You had a 2, 11, 15, 7, 10. Okay, let's say you have 7 here. Okay, and let's say you shuffled it like this. Okay, you can shuffle it in any way. And after that, you have to perform some operations in this to make it a palindrome array. So what is palindrome means? It means the first elements would be equal to last second, and then if it is odd, then the middle element doesn't matter. If it is even, then you have a pair of everything. So you have to make this 2 and 10 equal. How can you make them equal? You have k equal to 2. So you can, only thing you can do is increase some element by k. That's the operation. You can increase this 2 to 4, 4 to 6, 6 to 8, 8 to 10. That way you would get a 10 here, and then 10 would be equal to 10. So how many operation it required? It was from 2 to 10, 4, 6, 8, 10. So a total of 1, 2, 3, 4 operations. So in 4 operations, you made this as 10. So it required 4 operations. Now from 7 to 11, you can make it 9 and then 11. So in 2 operations, this would also take. So, and this 15, it doesn't matter. So in total of 4 plus 2, 6 operations, you are able to make this array a palindrome. Now, maybe you would have, if you had, let's say, something 7 and 11. So in this case, this was actually the best. So if you had, let's say, if you shuffle this array like this, and you had 11 here and 15 here, then how many operations you would require? From 2 to 10, it would again take 4 operations. But from 7 to 15, 7 would be changed to 9, 11, 13, then 15. 4 operations for this also. So in total, it would take 4 plus 4 equal to 8 operations. So you can see you have to shuffle in such a way so that the operations required is minimized. So in the first case that I took, in 6 operations, we were able to make it palindrome. In the second case, in 8 operations, we were able to make it palindrome. So our answer would be 6. Okay, and let's say if I take, if I shuffled it like this, 2 here and 11 here, then can we make this 11 to 10? We can never make it. So in this case, we can never make it a palindrome. So we won't consider these shuffling cases. So we have to shuffle in such a way so that after using operations, we can make it a palindrome. And if it is not possible to make it a palindrome by shuffling in any way, then we would print -1. Okay, that's what we have to find. Now, if you look at this, so the question should be clear now. So if now what can we do? Okay, so first thing that you can look is the first element and the last element. You can just consider them like a pair. You want to make this pair equal. Okay, the second and last second, you can consider them like a pair. You want to make this pair equal. And if had a bigger array, then the third and last second, fourth and last fourth, likewise. Okay, you can consider these elements as a pair. So you have to take pairs of two elements and make them equal. So if n is even, you would have like n by 2 pairs. And if n is odd, then one element you can just place in the middle, which won't require a pair. And then remaining n by 2 elements, there would be n by 2 pairs. Okay. So now in pair, what does that mean? So if you have a 2 and a 10 as a pair, it means you want to make them equal. To make it a palindrome, you want to make 2 and 10 equal. So how can you make them equal? By increasing 2. If you have k equal to 2, you can do +2 and make it 10. So in like 10 minus 2 by k, you can say in these many operations, you can make it equal if 10 minus 2 is divisible by k. That's the important criteria. So if you had k equal to 3 here, can you make this 2 equal to 10? In any case, you cannot, because from 2 you would go 5, from 5 you would go 8, and from 8 you would go 11. You would not reach 10. So the first important criteria for two elements to be in a pair is their difference should be divisible by k. That's the first important criteria for two elements to be in pair. And what would be the number of operations required? So number of operations would be difference divided by k. Okay, this difference divided by k. These many operations. And this thing you have to minimize. So there are two things. You have to make pairs such that the difference is divisible by k. And you have to try to take such pairs so that the number of operations is difference by k is minimum. These are your two targets. Okay. So first thing we would have to check is this thing. If two numbers are, the difference of two numbers is not divisible by k, you cannot place them together. So that's the first thing. So this thing would be checked afterwards. First thing is this. So what two numbers can you take whose difference would be divisible by k? So if you see difference, it means, let's say the smaller number is x and bigger is y. The difference is y minus x, and you are telling that y minus x modulo k should be 0. So if you open the bracket, what you can get is y modulo k minus x modulo k, and like plus k modulo k. If you use the property of modulo, you would know. So this way we can write it like this. So if you take a look, what does it mean? It means like this thing should be a multiple of mod k is 0. When would these be a 0? When these two would be equal. If you see that, if you take this is 0, if you take that, if y mod k is equal to x mod k, in that case only, because y mod k is always less than k, x mod k is always less than k. If the difference of these two is 0, then only 0 plus k would be a multiple of k. If the difference is some negative value, then k minus some negative value would never be 0, because it should be k minus k. And you cannot, both are less than k, you cannot have the difference equal to k. The difference would also be less than k. So less than k, only difference, valid difference you can have is 0. So you can understand from that both of the numbers modulo k should be same. That's our condition actually. Okay. Yes, no, yes, yes. Okay. It's clear now. So it means if you take this, the array that we are given, if you make all the elements, whatever element you have, if you do modulo k to all the elements, okay. If you do AI modulo k for every element. Now, the two elements whose AI modulo k are equal, they can be placed together. So we can just group this array on the basis of AI modulo k. So what we can do, we can take a map. Okay, what we can take a map of actually int comma vector. So what does that represent? The map of, let's say, x represents all those elements. This would be a vector of all those elements whose AI modulo k is x. So if some element has an AI modulo k x, so the remainder by dividing it with k is x, then we can place that element inside the map of x, because all these, the group of all these elements would be the elements who can be paired up together. You cannot pair an element, so you can just actually, you are dividing this vector into groups of vectors where each group represents that the elements inside this group can be placed together. That's what we are doing. Okay. So this way, let's take an example to let's take this above example only, which we were discussing. Here, if you see, if you do modulo 2, this modulo 2 would be 1, 1. This was 2, 0, 1, 0. So it means map of 0 would have all those elements having 0. So 2 and 10. It would have 2 and 10. And map of 1 would have 11, 7, and 15. So what it means, this 2 and 10 are grouped together, 11, 7, and 15 are grouped together. It means you can pair up this 2 and 10 together, and you can select any two elements and pair them up together from this. Okay. So this way, if you had k equal to 2, we would have map of 0 and 1 only. So if you had k equal to 3, we could have map of 2 also. Okay, someone would have a remainder 2, those would be placed in map of 2. So at max, we would have like 0 to k minus 1 would be the range of my maps, and we would have vectors inside. So the overall size of this would be the size of this vector only. So overall, it would be size of O of n only. Okay, it won't be n square. You can understand that, because there are in total n elements only. At max, you would place n elements in this in total. Okay. So now, once you have divided this into maps, okay. So let's state it clearly here. So if you have 2, 4, 7, 9, 5, 8. Let's say you have this array, and you have k equal to 3. So what you would do? You would do modulo through 3 first. This would be 2. This would be 1. This would be 1. I'm doing modulo 3. Okay, I'm taking remainder with 3. And this would be 2. So according to these values, you would group them. So map of 2 would contain, map of 0 would contain this 9. Map of 1 would contain this 4 and 7. Map of 2 would contain 2, 5, and 8. Okay. So now, once you have grouped them, now you can make pairs inside a group only. Okay. So you can make this 4 and 7 as pair, 5 and 8 as pair. So the first condition to check if we can make it a palindrome is if you have a group of odd size. So this is an odd sized group. It means you cannot pair up all the elements. There would be one element which would remain. This is also an odd sized group. So this one element would remain. So if you have, like, in this case, you can see one element from here would always remain lonely, and one element from here would remain lonely. So in total, 1 plus 1, 2 elements are going to remain like lonely, which are not paired up. So we cannot have, if you have more than one element which is not paired up, then we would print -1. Because in palindrome, if you have odd n, then the middle element can remain not paired up, but all the remaining elements should be paired up. So at max, we can have only one element which is not paired up. Okay, we need to have all of them paired up. So in this case, the answer would be -1. Okay, but let's say I update one more element here in my array. let's say I take a 3 here. Okay, so 3 modulo 3 would be 0. So you would have a 3 inside here. Okay, now let's take this example. So now what we can do? Now the next thing we have to do, we can pair them up. Now we have to pair them up in such a way so that the number of operations is minimized. Now what would be my number of operations be? So for 3 and 9, my number of operations is going to be 9 minus 3 by 3, which is 2. Okay. For 4 and 7, my number of operations would be 7 minus 4 by 3, which is 1. Okay. So 2 operations here, 1 operation here. For this, we have to select 2 numbers and 1 would remain unpaired. So if you select this 2 and 5, my number of operations would be 5 minus 2 by 3, 1. For this, we would have 1. If you select 5 and 8, you would have 1. But if you select 2 and 8, let's say you selected 2 and 8, the number of operations would be 8 minus 2 by 3, which would be 2. So you would require 2 operations if you make this 5 lonely. But the better option was to select 2 and 5 and do it in one operation and take it as lonely. Okay. So you would select the better. So how can you select the better one? So actually, if you see and the answer you're getting is the difference between the two. So if you sort this array, so this is already sorted. If it is not sorted, you can sort them up. And then you can take the minimum differences. So if you have a bigger array, let's say 11 and 14 are also there. Okay. Now you would take 2 pairs out of this. So you can take 1 pair as this and 1 pair as this. Let's say you have 17 here. Okay. So you can take these 2 pairs. So it would be one operation here, and this is 11. Okay. This would be one operation here, and this can be kept only. That's one way. Or you can take this pair, and instead of taking this, you can take this. So here it would be 2 operations. 1 plus 2 is greater. So in case of even, if there are even elements, only 4 and 7, then it's fixed. You have to pair up every element. So if it is 4, 7, 10, 16, it's fixed. You will have to do 4, 7, and 10, 16. Okay. So you would never do 4, 10, and 7, 6. If you are doing a cross like this, after sorting, you are taking more differences. So you would always do. So for even case, you would always take first 2 elements, difference between first two, difference between next two, difference between next two. Likewise, that would be your minimum difference. And for odd case, you would have to one by one pick every element as the element you are leaving and then check. So for odd case, it would be a little more complicated. Okay. So what I am doing in the odd case, so listen very carefully. First thing I can do from here, instead of taking these values as 9 and 3, if you, what I'm requiring from this, I'm only requiring the number of operations. Number of operations would be 9 minus 3 by 3. So why don't you divide this 3 before only? It would remain the same. It won't affect our result. If you have 4 and 7, instead of doing this 7 minus 4 by 3, we can do 7 by 3 minus 4 by 3. Take the integer divisions. It would remain the same. Is this thing clear? So instead of doing a by k every time, what you can do, you can just take the array only, like inside the map only. Instead of putting the AI, you can put AI by k. So instead of 9, you would have 3. Instead of 3, you would have 1. Now, to calculate number of operations, you can directly take the difference. 3 minus 2, and 2 operations you can do. Instead of 4, we have 4 by 3 would be 1. Integer division, we are going. 7 by 3 would be 2. So difference is 1, so 1 operation. Here also, 2 by 3 would be 0. 5 by 3 would be 1. 8 by 3 would be 2. So 1 operation here, 1 operation. If you take this here. Okay. So the first thing is in the map, how we are storing. We are storing map of AI modulo k in that we are going to just push back AI by Q. In this way, we are creating our map. That's the first thing, how we are creating our map. In this way, we are creating our map. In the AI modulo K part, we would push back the element AI by Q. So that we could have pushed AI also, but it would be easy to calculate the differences. We don't have to do by Q every time. Okay. Uh, Okay, so like I'll come to that odd case if you are having a confusion how it would be O of n. So like if you take the brute force approach in the odd case, it would go O of n square. So we have to optimize it to O of n. Well, I'm coming to that, and odd we can skip it. Okay. Okay, so except the odd case, what I have explained till now, it is clear now. I'm coming to the odd case. Okay. Okay. So this is how we are creating the map. Now, inside the map, what we are doing. So if you have the elements as even, first we would sort them. So after sorting, if you get 1, 2, 4, 6 like this, and they are even, 8, 10 like this, we'll just this difference plus this difference plus this difference. We'll do 2, 2, and 2 here. So we will get 2 plus 2 plus 2 as 6. So we'll add 6 to our answer like this. Now for the odd case. Odd case, what we can do. So let's say you have 1, 3, 6, 10, 12, something like that. Okay. Now, in this case, the first thing that I told, you would have to take cases. If you exclude this, then you would have this plus this. Okay. If you exclude this, you cannot exclude this. Or if you exclude this, you would have this plus this. Okay. So having this difference is same as this difference plus this difference. So why to exclude this when you are not getting any benefit? You are just adding up all the differences. So it would be better to exclude any other. Okay, so now if you exclude this 6, this plus this. Now if you exclude this 10, you would get this and this. So it's better not to use this. Okay. Now if you exclude this 12, you get this plus this. So the first observation is you would exclude either first element or third or fifth. So like this, you would exclude. So if you have a zero-based indexing, 0, 1, 2, 3, 4. So only you can exclude either this, or this. Only the even indexes you can exclude. That's the first thing. Now, how can we compute our answer? If you one by one exclude this and then compute, it would be O of n. Exclude this and then compute O of n. So it would go O of n square. So you don't want to do it O of n square. So how can you do in O of n? So what you can say, if you exclude this element, you are calculating for this prefix and for this suffix, your answer. If you exclude this, you are calculating for this prefix. If you exclude this, you can calculate for this suffix. If you store a prefix array and a suffix array of your answers, you can then, if you pre-compute a prefix array and a suffix array, you can then compute your answers in O of 1 for each case. Okay, so is the idea of the prefix array and suffix array clear? So like how I'm calculating the prefix and suffix array, tell you know. So what you can store for the prefix array, you can store, let's say your prefix I represents that if you take this subarray from 0 to I, what is the minimum difference you would get if you pair up all the elements in this prefix? So first thing is this I would be what you can take this 2 or take 4 or take 6. You can never take like these 3 elements. If you take these 3 elements, so you cannot calculate a prefix for them because you cannot pair up all the elements. First thing is you would pair up all the elements. So this I would always be either this, so 1, either this, so 3. So I would always be odd. So you would compute your prefix array for odd indices only, not for even indices. Okay, and about your suffix array, you would calculate a suffix of this, okay, or you would calculate a suffix of this. So 3 or 1, again odd. So you would have to calculate your suffix array for odd indices only. Okay, so I is odd only. Okay, remaining even indices of prefix array can be like blank, empty, or it doesn't matter what they are. You can just store 0 or anything like that. So you can compute a prefix array. So first you will initialize your first one would be prefix 1, only odd indices I'm considering. I'm taking 0 based indexing, that way. If you take a 1 based indexing, you will get even here. Okay, so that you can manage. So first prefix of 1, it would be the difference between these two. So it would be like a of 1 minus a of 0. This would be your base case. And then you can run a loop for I equal to 3 to less than n with I plus equal to 2. You would go, okay. And in this loop, you can assign prefix I is equal to prefix I minus 2, what you have calculated till I minus 2 plus. So if you are calculating for this prefix 3, so if you have calculated till here plus this difference, so it would be plus a of or whatever vector you are having. So a was original vector. This would be this subgroup vector. Okay, I'm representing it with vec. Okay, this would be the vector for this group. Okay, for the map of whatever I'm taking. So vec of I minus vec of I minus. So in this way, you are going to pre-compute your prefix array. And same for suffix, you can just take the last value as your base case. So you can write that. I'll show that in my code on this. Whatever the size you are having for this vector, size minus 2, you would start from there. And that would be suffix of size minus 1 minus, sorry, vec of size minus 1, vec of size minus 2. So the difference of these last two elements. For your last suffix, this would be the difference for suffix of size minus. Okay, and then you can run a loop and compute similar to this. It would get a plus here, and then this. That. So you can pre-compute your prefix and suffix array. After that, what would your answer be? So for each case, so if let's say you are excluding this, you would write prefix of I minus 1 plus suffix of I plus 1. You would add these two up and you get it. So for calculating the answer, you would initialize like, let's say sum equal to 0. And then you would minimize this. So minimize this sum. So for you would run from I equal to, as I told, for which indices you can exclude. You can either exclude this or this or this. So only even indices. So you would run your loop from I equal to 0 to I less than n and I plus equal to 2. You would run and you would check your sum as min of sum comma prefix I minus 1 plus suffix I plus 1. That's what you are going to check. So this way you can minimize, and this finally you can add answer plus equal to sum. This would be the for this. I'll show you the code anyways. So did you got the logic? Please tell this again. Why just odd? Why just odd for I? So like as I told, okay, maybe you didn't. Okay, if you have a doubt that can I exclude this value? So if you have this array and I exclude this value, okay, then what would be the so I'm excluding this value, then what would be the sum of differences, the number of operations we would get? So you would have to include like this. So 1 minus 6, you would have this difference as 5, and then this difference. So this would be 2. Okay. So if you, this 5, what is 5? It is difference of this plus this. So you're actually taking both of these differences. But had you excluded this thing, you could have taken this, only this difference. And had you excluded this thing, you could have taken only this difference. So by excluding this or this, you could have taken only this or only this. But by excluding this, you are taking the sum of both of them. So it's always better to take either this or this instead of taking the sum. So it's always better to exclude either this or this instead of excluding this. So did you got the logic? Why we are only going excluding even indices? And if we are only excluding even indices, we would need prefix of I minus 1. I is even, I minus 1 would be odd. And if we are excluding this, I plus 1 would be odd. So we only need to pre-compute our prefix for odd indices, prefix and suffix for odd indices, if we are excluding an even index. Okay. Okay, got it. So I hope this logic and everything is clear. We can move to the code. Prefix and suffix part again. Okay, I'll explain the thing you understood now. Like if I am excluding this, I would need the prefix of this and suffix of this. Okay, so you have the doubt how we are calculating this prefix and suffix. Now,
Oh, no, actually, why we like how are we calculating? Like, let's say if I skip, I got the part where I'm skipping
yeah,
either like all the even indices, but like, how are we calculating? Like, let's say,
how are we?
I s-
Yeah. Okay, I'm coming to that only, how we are calculating. Okay,
yeah,
I'll show you with the code only. Okay, I've written the pseudo code here only, so let's show the actual code only. Then you would understand how we are calculating. Okay, so like first what we are doing, we are computing our map. So I've taken the input and my map would be int comma vector of int. So this is our map. And for every element, I am doing map of AI mod k dot pushback AI by k. So I hope this thing is clear. As I had explained earlier, uh, how we are calculating our map. It is map of AI mod q dot pushback AI by k. We are doing divided by k here only, so that while computing our answer, we don't have to do divided by q every time. Okay. So you could have taken AI only there. So while computing, you would have to do by q. So this is the map we have constructed. Now this remainder is just storing that how many values we can take alone, like how many alone values you can have. So if n is even, you would have 0 values which you can keep alone. You would have to pair up all of them. And if n is odd, you would get a 1. So you can have one element which can be kept alone. Okay. So that's the first thing, so that we can calculate if we get a minus 1. Now, now we are going to every element of the map, and this it dot second would be our vector. So we got a group. Okay. So I have taken this vec. It would be it dot second. So now you have to compute your answer for this vec, for this group. I have taken the size of vec as z. Now, first thing I did is I have sorted this vector. Okay, so that it's easy to compute the answer. And if it is odd, so I've written the odd case. So if this is the odd case, and if it is not odd, then for even case, it's simple. We can just add up. We can move to every odd index and add up vec I minus vec I minus. So we do in the steps of 2 and add up the differences. So if it is even, what we are doing? So 1, 2, 3, 4. If it is like that, so this plus this we are doing. So we are moving to every 0, 1, 2, 3. So we are moving to every odd indexes and adding these differences. Vet I minus vet I minus. So this thing we are adding for every into 2 steps. We are adding this. So this is for even case. It's like simply this one. We're adding this to our answer. Now for the odd case. So if our remaining value is 0, it means we cannot have an odd case. So we'll print -1 and return. That's the first thing. And if we have one odd case, we'll reduce our remaining value. It means we cannot have more than one odd case. So if my rem was 1, it would become 0. So next time if we get an odd case, we would try to return -1. So that's the first thing. Now, if we can have an odd case, I'm computing. So first a small base case, if the size of the vector is 1, just that would be alone, there would be no pairs. I'm doing continue. So if the size is 1, there would be no pairs would exist. So nothing would get to our answer. Now, if for size greater than 1, I'm taking a prefix array and a suffix array. So this prefix array I'm taking of the size and suffix also size, but actually we would only require odd indexes in that. So first I'm taking the base case, which is prefix of 1 is vec of 1 minus vec of 0. So if you take a look at this, what does my prefix of 1 represent? It represents number of my value, my answer for this array. For this array, we can have only this pair between 0 and 1. So it would be difference of these two, vec of 1 minus vec of 0. As I had written, prefix 1 would be vec of 1 minus vec of 0. So this base case is clear. Then I would run my loop. So if I go to this, if I'm calculating for prefix 3. So I would write its prefix of 1, whatever I got here, plus this difference. Then if I had a 5 here, I wanted to calculate for prefix of 5. So for this, I would say the prefix I got up till 3 and then this difference. So what relation I can write, that prefix I is actually prefix I minus 2 plus the current difference. Current difference is vec I minus vec I minus. So this would be our transition for prefix array. So this is the base. Prefix 1 is vec 1 minus vec 0. And from I equal to 3 to less than size, we are moving the steps of 2, so that we are going only to the odd indexes. And prefix I would be prefix I minus 2 plus vec I minus vec I minus 2. This is our difference of the current, the ith and the I minus 1. And this is our from the last prefix. Okay, so is this the prefix computation clear? Was having the dot just right? Yes. Okay.
Yeah, prefix is like I got it.
Okay, now let's come to suffix. Okay, so suffix, what would our base case for suffix be? So if I'm calculating for the first suffix I would have would be the last two elements. So if this is an element of size 5, you have indexes from 0 to 4. So our size would be 5. So this is size minus 1 and this is size minus 2. So I would compute my suffix for size minus 2. That would be my first suffix that I would compute. That would be the difference between size minus 1 and size minus 2. These difference. So the base case would be suffix of size minus 2 would be vec of size minus 1 minus vec of size minus 2. Okay. If size was 5, this is 3, this is 4, this is 3. So vec 4 minus vec 3 is my suffix 3. So suffix 3 was vec 4 minus vec 3. Okay. So the base case is clear. And then transition, how we can write. So what we can say, if we have to compute for this suffix, okay, after this suffix would come. We are only calculating for odd indexes. So for this suffix, we can say it would be this suffix up till here plus this difference. Okay, so we can just write the suffix of I would be suffix of I plus 2. Okay, suffix of I plus 2 till here, and then the current would be suffix of I plus 1 minus suffix of I. So this is I plus 1, this is I. So difference between these two would be my current. Okay, so this is the transition for suffix. Okay, I have not written here, I have written here. Okay, so this was the base case, size minus 1 minus size minus 2. And in the, for the loop, we would run from size minus 4. After size minus 2, we would get size minus 4, greater than equal to 0, minus equal to 2. We would go in the steps of 2. Suffix I would be suffix of I plus 2 plus the current difference, which is vec I plus 1 minus vec I. Okay, so is this clear how we are calculating suffix and prefix?
Yeah,
Yes.
got it.
Okay. So once we have calculated our suffix and prefix, our transition would be just, so my sum would be, I'm initializing with 0. So I'm just checking if I is greater than 0, then prefix I minus 1. So if I'm at I0, then I minus 1 would become negative. So like for the starting, we would have no prefix. If I is greater than 0, then only I'm doing sum plus equal to prefix I minus 1. And if I is not the last value, if it's not size minus 1, then only we're doing suffix I plus. Okay. Otherwise, it would get suffix of size, which would be invalid. Okay. So this way, we are just doing sum equal to prefix I minus 1 plus suffix I plus. And then we'll take the minimum of all of the sums. Okay. So I'm initializing a minimum variable with infinity, and minimum of all of them would be my final, the minimum value that we can get for pairing up, and in case of odd, then answer plus equal to minimum and continue. So this way we would get our final answer. So is this clear? Any more doubts in this? Okay, so if you look at the complexity of the code, we have taken a map, and in that map, at max, we are inserting n elements into the map of vector. So n times, and insertion would be log n. So this whole thing would take a n log n. Okay. Because insertion in a normal map is log. Okay. Now, in the loop, what I'm doing, I'm running to each element of the map, and this vec would have, so I'm running a loop for each of the groups. Okay. So every group will have a vector. Okay. And then inside that, I'm sorting that vector, and this prefix suffix is O of size of vector. This whole thing is O of size of vector. 2 pre-computations of prefix and suffix, and 1 this calculation. So 3 times the O of size of vector. Okay, so this whole thing would be, and you can take this also. So this whole would be the O of size of the vector. Now I'm doing this O of size of the vector for all the vectors. So sum of all the vectors would be actually n, because we have n elements. So sum of all the groups, the smaller groups, we are dividing them into. That would be n. So overall complexity would be O of n, and then if you are having any log n operations, we are not having. So this whole thing would be O of n, O sorting. We are doing the sorting, which is n log n. It would be n log n. Okay, it is size into log of size, because we are also doing the sorting thing. Okay, so overall it would be n log n for this. So n log n plus n log n, overall n log n. We have time complexity. So in our n log n, we are computing this is accepted. So I hope it is clear now. And so this was the discussion for today. So we can end the session now. I hope you liked it.